We are Team ID 19902. Our problem statement title is Real Time Disaster Information Aggregation Software. We are here to showcase you the technical approach of our proposed solution.
The first phase of our technical approach is data collection. In this step, we have utilized GCP, MongoDB, Kafka, and Selenium. We have initialized three producer streams which will gather information from news articles, social media, and another feature which is self-reporting. This all information is collected in Kafka in specific topics such as social media and news articles. These topics will be consumed by a pipeline which will send the information back to the MongoDB database.
The second phase of the technical approach consists of clustering and classification of disaster based on its type and location, which includes the following steps. First step is preprocessing, which consists of removing punctuations, stop words, lematizations, etc. Second step consists of real and fake news classification, which is followed by manual annotations of false negatives. Third step is clustering the real news. Fourth step is creating the summary of the particular cluster. Now we will see the particular phase in detail.
So our approach to this is in real time we extract the text ID and the text of the sources from the database, and this is right now we have extracted one of the small data sets from the database in real time. Once you have done that, we are going to cluster it on the base of the similarity of the sources. So if you can see here right now, we have first of all clustered all the earthquake and Surat articles together. Similarly, for cluster 1, we have the Bihar and monsoons articles together, and similarly for cluster 2, we have clustered droughts in Ahmedabad. Once you have done that, we are going to use a summarizer and we are going to extract the summary on the base of all of those articles. So all of the articles of cluster 0 are going to be used to extract one line of summary for the same. Similarly, all of the articles of cluster 1 will be used to get the summary in one line of those articles, and similarly for cluster 2 as well, and for so on for as many clusters as possible in real time. Once you have done that, we are going to extract the locations of those places where the disaster is happening in real time on the base of the summary created, and also the predicted label, which is through a model we are going to use to classify all the disasters, and we are going to get the predicted label. So for example, of cluster 0 we have earthquake, for cluster 1 we have flood, and for cluster 2 we have droughts. And then all of this information will be displayed on the dashboard in real time.
Now we will see our front-end component, which includes the dashboard and interactive map.
As you can see on the screen right now, we are on the alerts page of the dashboard. From the previous step, the clustered information will be available in this page. As you can see on the highlighted portion right now, this is the summary of an earthquake in Surat, and if I click on the sources button, the information from different sources, which includes X, social media and news articles, it will be present here for verification. Along with this, we also have a score which will determine the authenticity and collection of the collected information. Next is the map explorer. The clustered information will be present here for an easier user experience, and by hovering or clicking over the particular disaster, we can get to know more details such as the location, score, disaster type and severity. Of our application is self-reporting. This feature will be available to other agencies and officers which can directly report a disaster along with the images and videos.
To conclude, we have the following key features, which includes automated data extraction and API integration, real-time alerts, self-reporting platform, data visualization using interactive maps, real and fake news verifier for better aggregation. Thank you.